Thank you, Professor Slash. Yeah, I'd like to share that my presentation.
Okay, so the first speaker will be Professor Kosugi. So he will introduce about the project and also about the work that has been carried out in both Malaysia and also in Japan. So Professor Kosugi, whenever you are ready, the screen is yours.
Okay. Just hold on. Can you see my presentation?
Yes.
Is that okay?
Yes, clear.
Yeah. We
Can you
see.
hear me? Oh, okay. Thank you for kind this introduction to me, Professor Jawadi. My name is Akihiko KOSUGI. I'm from the JIRCAS. JIRCAS is one of the research institute. Agriculture, forestry, and fishery in Japan. This SATREPS project is a national research project between the Malaysia government and the Japanese government, founded by Ministry of Education, Malaysia, from the Malaysia side, and JST and JICA from the Japan. SATREPS is also abbreviation of science and technology research partnership for sustainable development. This project is doing a collaboration between the Malaysia side, USM, MPOB, SIRIM, and FRIM. Also, Japanese side, IHI Corporation, Hiroshima University, University of Shimane, National Institute of Environmental Studies, Panasonic Corporation, and Nissin Shoji. This project is conducted by industry, academia, government sectors. We appreciate for giving this opportunity to introduce our research activities. I'm very pleased to join many scientists and interest to this session. My presentation is just introduction of a background for this SATREPS OPT project session is so long. Please relax to hear our presentation and stay with us until end. As you know, palm oil is the most produced and consumed in the world. The oil is important and indispensable vegetable oil that supports the social economic of many countries and regions. If same amount of oil supplement with the other crops, it is necessary to develop the agriculture land with area 10 times larger. However, this is always argumentation about the impact on the global environmental and social issues due to management of oil palm plantation and the production of palm oil. It seems that improvements have been made considerably for land conversion and competition with the food. However, it still so remains environmental issues such as how can industry that produce more than 80% of waste be transformed into the sustainable industries. What kind of a scheme so can we combated the sort of win-win situations? So we'd like to consider that the issue of palm plantations and make a way to more sustainable palm plantations. As you know, so palm tree, so we call this OPT, are cut down and replanted at the interval about the 25 years due to decline in the fruit productions. So I show you the video that is a logging, so OPT. So can you see the video? Okay. All OPT is pushed down, so using the heavy machinery. So usually contractor slice OPT because of preventing pests such as beetle. So this sliced OPT leaves the plantation area and wait to be degraded or mix the soil. The replanting is about the 4,400 square kilometer each year. That's the same area 2 times Tokyo. The discharged volume 180 million tons per year as a dry biomass. Unfortunately, only a few percent of a logged OPT was utilized as a plywood. Almost OPT is not utilized and discarded to plantation area. So can we add value to this OPT biomass and reuse or recycle them without environmental loss? So we are trying to provide the two research developments, which is becoming economical incentives and environmental incentives. We believe it is so essential to establish these incentives to realize OPT and palm biomass utilization. Okay. According to Hanson and several reports, the photosynthesis ability of OPT is 2 or 3 times so higher than forest, and majority of the CO2 may be fixed to fruit bunch. The ability of the CO2 fixation is stronger than tropical forests. On the other hand, even fixed many CO2, 80% this biomass is discharged as a waste, and it's not efficiently utilized. OPT composed of lignocellulosic solid fiber parts and liquid moisture parts as a sap contain the sugar. The ratio is around 30% so solid and 70% liquid, such as sap. Therefore, it is necessary to consider the effective utilization methods so involve SAP. The solid part composed of cellulosic materials is generally utilized to materials such as plywood and pellet. On the other hand, liquid part as SAP is able to convert it not only the biofuel and the bioplastic, such as some methane and plastic, but also so we can make the liquid fertilizer and the more interesting chemicals such as antioxidant. So we have a pilot plant for OPT utilization at Keluang in Malaysia. This pilot plant was established to construct for research and development for high quality pellet as first. Now we develop not only the pellet and the board fiber preparation, but also biogas production using the SAP. High sugar concentrated syrup from the SAP and the mineral recovery process from the wastewater using the membrane technologies. So we would like to show you about the process from the next and other speakers. So this figure shows the pellet and the fiber process flow in the Keluang process. So you can see chipping the OPT is going to process to water dipping machine. The water, this water dipping machine here. The SAP components removed almost 100% from the OPT chip through osmotic pressure between the water and the SAP. To remove the mineral in the OPT fiber, the fiber treated the wet grinding and proceed pellet. So if the fibering is necessary to prepare the board, the fiber going to process into the extruder. On the other hand, to recycle the wastewater, so methane is also effective produced from the IC reactor and used as a biogas. The sludge water is going to final effluent after recovery, mineral, or produce the value added, so bioproduct. Also, water. After treated, that water is going to back this dipping machines. So in this way, the Keluang process is designed as a zero emission, zero waste system. The most particularly great features of Keluang process is the zero emission, zero waste, and the recycle process. We think the resulting pellet is definitely carbon neutral. For example, when OPT transported from the plantation to process and exported the Japan. According to our calculation, GHG emission will be carbon minus. This depends on the ability to efficiently biogas from the sap, which is also highly organic waste liquid. We can say that pellets produced by this process are highly sustainable. So another recent activity and the trial for high value added technology, we found the new functional activity of OPT sap. OPT has a strong photosynthetic abilities, but at the same time, it's considered that it's received intense ultraviolet rays. If OPT or OPT sap has a ROS scavenging capacity, it is quite interested in the resource of cosmetic and beverage. So we measure that the scavenging activity for alkali radical, hydroxy radical, and singlet oxygen as a major free radical using ESR machine. So as a result, quite interestingly, OPT sap has a higher scavenging activity for these radicals than aloe, cucumber, black teas, green teas, and blackberries. So x-axis is the y-axis is the abilities of the scavenging capacities. So these results mean the increase of the new resource value of the OPT and contributed to promote utilization of palm biomass. So in other hand, the sustainable procurement system is necessary to construct for social implementation of technologies. Because procurement of biomass has always problem of collection, distance, cost, and seasonal yield, which are very unstable factors for scale-up applications. To establish the applicable way for OPT utilization, we encourage the establishment of two incentives. So before I taught, to avoid the two incentives, so scale up of industry is necessary because of keeping a balance of between the two incentives. That is very important. For that purpose, this can be seen that is independent of the palm plantation and the oil palm mill, but it would be ideal to have integrated the management. For the collection of raw material and diversification of raw materials should provide the economical and environmental benefits. In addition to this, it may solve both programs in plantation and palm mill. I just introduced TSO over view of SATREPS OPT projects that will surely create the circular economy like this figures and promote the sustainable land use, GHG reduction, increase of activity, and employment in the local. If so, you have interest in our activity, so please contact us, and so let's extend it this kind of ideas so with you to palm industry and the other crop. So this is the last slide. This project is supported financial by Japan Society Science and Technology Agency, JST, Japan International Cooperation Agency, JIRCAS, and the Ministry of Education, Malaysia. Thank you for your attention.
Okay, thank you very much, Professor KOSUGI, for the very nice presentation on the overall project objectives and achievements of this SATREPS project.